So we've talked about systems of equations. Today we are going to talk about systems of inequalities. So first of all, inequalities are things that are written with x's and y's and have greater than, less than, greater than or equal, or less than or equal signs. Okay, so they're very similar to what we've done before, but the solutions to these inequalities are going to possibly be a lot of solutions rather than just a couple. So a solution is still going to be written as a point, but we may be able to write lots of solutions. So we're going to look at the graphs of linear inequalities, a lot of graphs. So remember, you're going to be graphing lines the same way you've always graphed lines. But when you graph a linear inequality, you also have to graph whether it's dotted or solid, and you have to shade appropriately. So how do we graph? Well, step one is to replace the inequality sign with an equal sign and graph the corresponding linear equation. So basically, graph it like you would graph it a line. Okay? Then you're going to decide if that line is solid or dotted or dashed. Okay? It's solid if it's less than or equal or greater than or equal. And it's dashed if it's less than or greater than. Then you're going to choose a test point that is not on the line. Not on the line. Okay? And you're going to substitute it in to the inequality. And if it's true, you shade on the side of the test point. If it comes out false, you shade on the other side. My test point is almost always 0, 0. As long as 0, 0 is not on the line, that's what I tend to test by. So let's take a look at a graph here. So 4x minus 2y is greater than or equal to 8. So first of all, I'm going to pretend like it's an equal sign for a moment, and I'm going to figure out how to graph this line. Since it's in standard form, I have two choices. One is to use the x and y intercepts, and one is to solve it for y, and so that it's in slope-intercept form, and plot it from there. Now, I personally use the intercepts. So to find the x-intercept, we plug in 0 for the y. When I do that, 2y disappears because it becomes 0. And I get 4x, sorry, that's a time symbol. 4x equals 8. That tells me x is 2. That means I also know that I can write my x-intercept as the point 2, 0. Now I need to find my y-intercept. Again, that's going to be 0 something. So that means I'm replacing the x value with 0, which gives me 4 times 0 here, which is 0. So I get negative 2y equals 8. I divide by negative 2 on both sides, and I get y equals negative 4. So that tells me I have the point 0, negative 4. So I need to graph this line. So I'm going to plot these 2 points, and I'm going to connect them. I do need to decide if I'm going to connect them with a solid line or a dashed line. So looking back at my original inequality, I see that it was greater than or equal. That's going to be the thing that I use to decide. Since it is or equal, I'm going to connect it with a solid line. Don't forget you do need to extend this line to the edges of your coordinate plane, and you need to put arrows at the end. Now, we want to pick a test point. I will test 0, 0 because 0, 0 is easiest to test pretty much all the time. And I like that it's not on the line, right? Remember, that's a requirement. So I'm going to plug 0, 0 into my inequality. So I'm going to replace x with 0, and I'm going to replace y with 0. So these are still time symbols. 4 times 0 is 0. 2 times 0 is 0. 0 minus 0 gives us 0. So is 0 greater than or equal to 8? Nope, that is false. And because it's false, I cannot shade on the side with 0, 0, which means I must shade on the other side. Okay, so since 0, 0 was false, 0, 0 is over here, I couldn't shade over there. I had to shade on the other side. That is my linear inequality graphed. So, what if I want to graph something that's not linear? Well, same general method. I'm going to graph it just like I would if it was an equal sign, and then I'm going to test a point and see where I shade. So in this case, x squared plus y squared is greater than or equal to 16. We could write it as x squared plus y squared equals 16, which is the equation of a circle whose center is at the origin, which is 0, 0, and whose radius is 4. Well, that's pretty easy to graph. I have my center at 0, 0, and I count right 4, up 4, left 4, and down 4, and connect my dots. Ta-da! So graphing, pretty quick. Now we need to choose a test point. So I'm going to pick 0, 0 again, because it's not on the circle, so I can do that. I plug in 0 for the x and 0 for the y, and I get 0 plus 0, which is 0. Is 0 greater than or equal to 9? No, it is not. So that tells me that I cannot shade where the 0, 0 is. Notice that when we're talking about a circle, we're talking about inside the circle or outside the circle. Since 0, 0 was inside the circle and I'm not allowed to shade there, that means that I'm going to have to shade outside of the circle. And now I've graphed this inequality. Now, let's take a look at an application. The latest guidelines, which apply to both men and women, plural, give healthy weight ranges rather than specific weights for your height. If x represents height in inches and y represents the weight in pounds, the healthy weight region can be modeled by the following system of linear inequalities. 4.9x minus y should be greater than or equal to 165, and 3.7x minus y should be less than or equal to 125. We want to show that the point 66, 130 is a solution of this system. So for example, someone is 66 inches tall, being 130 pounds is a healthy weight. Well, the good news is that's pretty easy to do. We just need to substitute 66 in for x and 130 in for y and see does it work. So 4.9 times 66 is 323.4. 323.4 minus 130 is 193.4. And that is indeed greater than or equal to 165. But remember, in order for it to be a solution to a system of any sort, it has to be true for both. So we need to also plug it into our second inequality. So 3.7 times 66 is 244.2. 244.2 minus 130 is 114.2, which is indeed less than or equal to 125. That's a true statement. Since it's true for both, we can say that someone who's 66 inches tall would be at a healthy weight if they weighed 130 pounds. So this is a solution for the system. So one of the things you have to understand is you can come up with a solution to a system of inequalities, but there's actually the ability to find lots of solutions. So we're going to say the solution set of a system of linear inequalities in two variables is the set of all ordered pairs that satisfy each inequality in the system. We are generally going to solve this by graphing and shade where the intersection occurs. So notice that you are going to graph one inequality and shade, graph the other inequality on the same coordinate plane and shade, and keep where the two shaded regions overlap. Let me show you an example. Let's start with x minus 3y is less than 6. We're going to treat it like an equation, and we want to solve, we want to find the x and y intercepts. So I'm going to start by plugging in 0 for my y to find the x-intercept, and that gives me x equals 6, so I have the point 6, 0. Then I'm going to plug in 0 for the x and solve for y, and that gives me y equals -2. So I have the point 6, 0 and the point 0, -2. Then I'm going to do the same thing with my second inequality. I'm going to treat it like an equation, and I'm going to find the intercept. So I'm going to start by plugging in 0 for the y, and I get -3 for the x. Then I'm going to plug in 0 for the x, which gives me -2 for the y. So you see, I have two separate lines, and I have two separate pairs of points. So the first one had the intercepts of 6, 0 and 0, -2. So I plotted those 2 points, and I connected them with a dotted line. I know it was dotted because I had less than in the original inequality. I can plot my second graph using its intercepts, -3, 0, which was right here, and 0, -2. And I'm going to connect that with a solid line because it had a greater than or equals sign in the original inequality. Now, I want to test some points to try and figure out where I need to shade. So I'm going to test 0, 0 first. When I plug in 0, 0 to the first inequality, I get that 0 is less than 6. Well, I mean, that's true. And then I'm going to plug 0, 0 into my second inequality. I get 0 is greater than or equal to -6. Well, that's also true. So one of the things you have to understand is if I were to do this in colors, all right, the first inequality was the dotted line. I said it was true. So I'm going to shade on the side of 0, 0. The second equation, 0, 0 is true, and that's a solid line. I'm going to shade on the side of 0, 0. Where do these two shadings intersect? Well, they intersect in this piece here. So because that's where they intersect, that's our actual answer. So we're going to keep the piece where they overlap. Okay? So this is what that looks like when you have shaded the solution region. Notice that you're shading all the way to the edges of your coordinate plane. Now, I want you to practice graphing just one inequality using the x and the y intercepts. Then come back here to check your answer. So when x equals 0, this becomes 3y equals 6. Again, remember you're pretending that it's equals, which is y equals 2. So you have the point 0, 2. Then when y equals 0, this became x equaled 6. So that's the point 6, 0. I'm going to go ahead and plot those points, 0, 2, and 6, 0. And I can connect them, and I need to decide, is that a solid line or a dotted line? Since it's greater than or equal, I'm going to be able to connect them with a solid line. Okay, which is going to look like, hopefully, a straight line on our papers as well. Now I need to pick a test point. So I am going to test 0, 0 because it's not on the line. When I plug 0, 0 into the original function, I get 0 plus 0 is greater than or equal to 6. 0 is greater than or equal to 6 is false. Therefore, when I go to shade, I cannot shade on the side of 0, 0. I have to shade on the other side. So you should definitely use pencil only for shading because trying to shade with pen is really, really a struggle. Okay? But you'd shade on this side up here. It should go all the way to the edges of your coordinate plane. Ta-da! Okay, maybe not ta-da, maybe not beautiful, but that's okay. Love me anyway. Try graphing this inequality. Note that it's already in slope-intercept form, so it might be easier for you to graph. So here my slope is 5, or 5 over 1 maybe, and my y-intercept is 0, 3. So I plot 0, 3, and then from there I count up 1, 2, 3, 4, 5, and write 1. And you could also have counted down 5 and left 1. That would have been fine too. Okay. In either case, we look at this and say, okay, it says less than. So I'm going to connect with a dotted line or a dashed line, which is particularly difficult to do when you don't have a ruler. So having a straight edge of some sort will be very helpful to your lives for this section. All right, so again, make sure it extends to the edges. Now I look at this and I say, okay, 0, 0 is still not on the line. So I'm going to test 0, 0. Notice that it is required to tell me what you're testing because I can't just assume you're doing 0, 0. You have to tell me that you're doing it. All right, when I do, I get 0 is less than 0 plus 3. 0 is less than 3. So that tells me when I go to shade, I'm going to shade on the side of 0, 0. So 0, 0 is on the right side of this inequality. So I'm going to shade over here. Notice that you should fill this in much better than I'm doing right here. All right, so filled in entirely, but otherwise it'll look like that. Try graphing this inequality. So this is a vertical line because it's x equals a number, okay? And it's a vertical line through 5, and it is solid because it was greater than or equal. Yes, I realize that's terrible. I'm going to do a test point of 0, 0, and I get 0 is greater than or equal to 5, which is false. Therefore, I am going to shade on the right side where 0, 0 is not. So the key part of this is to remember that x by itself gives you a vertical line, okay? So y by itself gives you a horizontal line. Good. So just for giggles, we're going to say y is greater than 4. You're going to plot a dotted line through 4 horizontally. Your test point is 0, 0. 0 is greater than 4 is false. So you're going to shade away from 0, 0, which in this case is above. Ta-da! Now, I want you to graph the solution of this system of linear inequalities. That means you're going to graph all 3 inequalities and find where all 3 intersect. Your final answer should only have one piece of shading. So let's start with 3x plus y is less than or equal to 6. So notice that when x is 0, y is 6. And when y is 0, x is 2. So I can plot the points 0, 6 and 2, 0. I'm going to connect them with a solid line. Wow. I'm sorry. I'm going to have to try that one again. Oh, yeah. No. Just no. Give me a few more guide points here. All right. Straight line, solid line. All right, with arrows at the end. And then I also have x is greater than or equal to -6. So I have this here, which is a vertical line. And I have y is less than or equal to 4, which is like this. So notice that this gives us now 6 different places we could shade, okay, because this sliced this up into 6 different pieces. I'm still going to test 0, 0 and hope that it works for all of them. If it doesn't work for all of them, I just have to figure out what that means. So let's start with 0, 0 for the first one. Okay, I get 0 plus 0. Let me do this in color coding for you. So in the blue one, I get 0 plus 0 is less than or equal to 6. 0 is less than or equal to 6 is true. So that means I know I'm going to shade to the left of the blue line. Okay, because 0, 0 is correct for blue. Then for the red one, I plug in 0, 0. I get 0 is greater than or equal to -6, which is true. 0, 0 is to the right, so I'm going to go to the right of the red one. And then for the green one, I have 0 is less than or equal to 4, which is also true. And 0, 0 is below, so I'm going to go below the green one. So I'm going to shade to the left of blue, to the right of red, and below green. That's going to be this piece right here. And again, you'll want to make sure you use a pencil for this test. Absolutely. All right, that was systems of linear inequalities.